This is the second lecture in our little unit on algebraic foundations, and we're still discussing the foundations of algebra. Today we're going to add and subtract signed numbers. And before we start doing the arithmetic, let me do a little background on signed numbers. And the best way to describe those is elevation. And forgive your lecturer's lack of being Picasso here. Let's say this is a mountain next to the ocean. And the elevation at sea level, at the top where the water floats, is 0 feet. Anywhere in the world at sea level, the elevation is always 0. Okay, so if you are down underwater or a place below sea level, your elevation is negative. So let's just say this is negative 50 feet. Negative 50 feet. The elevation would be negative because it's below the 0 scale. Whereas if you're at the top of this mountain, up there, your elevation could be 3,000 feet. And it would be positive because it's above sea level. So if you're above, it's positive. If you're below, it's negative. If the temperature is below 0 degrees, which in Celsius, 0 degrees is freezing. So if it's below 0 degrees Celsius, water is frozen. And if it's above 0 degrees Celsius, water is not frozen. Okay. So, what we're going to do now, this lecture and the next lecture, we're going to perform basic arithmetic on these 4 signed numbers. And to do so, we're going to do so on a number line. And instead of drawing the scale every 4 times, I'm going to use the same scale on all 4 of these number lines. But let me explain the scale first here. So our number line, this represents the real numbers. And we're at 0, right in the middle. So numbers to the right of 0, notice that this is increasing because the arrow's on that side, are positive. So this is going to be positive 1, positive 2, positive 3, positive 4. And numbers to the left of 0 are going to be negative. They're going to be the ones in the hole, underwater, below 0, frozen, and so on. The negative numbers. Okay, so what I want to do now is explain, before I get into the formal how we add and subtract these, I want to give an explanation of what it means to add and subtract positive and negative numbers. Yeah, when we add and subtract, we're just going to add first. Add a positive number. So if we add a positive number to any number, no matter where we start, if we're adding a number to it, if we add a positive number to it, we're going to move to the right that many spaces. So if I say, what is negative 1 plus 3? Okay, negative 1 plus 3. I'm going to start at negative 1, and I'm going to go 1, 2, 3 places to the right because it says add 3. And that's going to give me 2. If we add a negative number, we move to the left. So, if I say, what is negative 1 minus 3? Negative 1 plus negative 3. I'm sorry. Negative 1 plus negative 3, since we're adding a negative number. Negative 1 plus negative 3. We're going to start at negative 1. And we're going to go, this is negative 1. And we're going to go 1, 2, 3 places to the left and be at negative 4. So negative 1 plus negative 3 is negative 4. Now, subtraction is the opposite of addition. They're inverses. Subtraction and is, so if we subtract a positive number, we move to the left. Because it's the opposite of adding a positive number, and we move to the right. So, if we say, what is negative 1 minus 3? Negative 1 minus 3. Oh, I forgot my little arrow there. We're going to start at negative 1. Let me put 0 on these so we can. And move 1, 2, 3 places to the left and be at negative 4. So, negative 1 minus 3 and negative 1 plus negative 3 are the same. If we add it, when we added a negative number, we move to the left. So if we subtract a negative number, and a good way to remember this is if you take away bad things, it's good, right? Taking away bad things is good. So we move positive in the positive direction. We move to the right. So if I have negative 1 minus negative 3, we're going to move to the right, and that's going to give us 2. Because we start at negative 1, and we move 1, there's 0, 2, 3 places to the right. Okay, so that's just a base description. That's not the procedure I want you to use, because this procedure, this takes way too long if we're dealing with numbers that are decimals or fractions or something that is much different than this. And in order to understand the shortcut, as you want to call it, we need to understand the concept of absolute value. And a lot of people struggle with absolute value. However, all the absolute value of a number, the absolute value is the size of the number or simply the number without a sign. So the absolute value is represented by these two big bars. We call that the absolute value of A. So let's look at some of the absolute values of these numbers that we have up here. The absolute value of negative 1 is 1, because negative 1 without the sign is just 1. The absolute value of negative 4 is 4. The absolute value of 3 is 3. And the absolute value of, I guess we have 2 up here too. 2 is 2. And also the absolute value is also formally defined as the distance between a number and 0. Notice that negative 1 is 1 unit from 0. Negative 4 is 1, 2, 3, 4 units from 4. But the absolute value is also, the easier way to say it and understand it, is it's the number without the sign. So the absolute value of negative 4 is 4. So now that we can do that, I'm going to show you the procedure, the proper procedure for adding and subtracting these. And we're going to start with addition. And just like multiplication and division, you're going to see that there's different rules for same sign and different sign, although they are very different. So first we're going to start with adding, and this is only adding. Adding numbers that are the same side. Adding numbers that are the same sign. Okay. So if they are the same sign and we're adding them, we add their absolute values. And the answer is the sign that is the same. Adding absolute values are the same sign. We add the absolute values, and the answer is the sign that is the same. For example, one that you already know how to do, 3 plus 4. They are the same sign. We add their absolute values. 3 plus 4 is 7. Both of these numbers are positive, so the answer is positive. So what about negative 3 plus negative 4? Well, we're going to do the same thing. Both of these signs are the same, and we're adding them. So we're going to add their absolute values. 3 plus 4 is 7. But since both of these signs are negative, the result is negative. So when we add numbers that are the same sign, we add the absolute values, and the answer is the same sign. When we add numbers with different sign, and this is where we get a little tricky, because the operations get tricky. If we add numbers with different sign, we subtract the larger absolute value. We subtract the smaller absolute value from the larger absolute value. When we add numbers with different sign, we subtract the smaller absolute value from the larger absolute value. The result has the same sign as the larger absolute value. For example, from the previous page, we said that negative 1 plus 3 is 2. So we're adding two numbers with different sign. So we subtract the smaller from the bigger. 3 minus 1 is 2. The larger absolute value is positive, so the answer is positive. What if this was 1 plus negative 3? We're adding two signs that are different. So we subtract the larger from the smaller. 3 minus 1 is 2, but the larger absolute value, which is 3, is negative. So the result is negative 2. And you can see that on the number line. If we start at 1 and we go back 3, 1, 2, 3, we're at negative 2. Subtraction is the same rules. However, subtraction is defined with addition. And this is where I lose some people sometimes, because these two operations are considered the same, because subtraction is defined by addition. So when we say A minus B, what we are saying is A plus the opposite of B. So when we subtract numbers, the rules are the same for addition, but we must first convert subtraction to addition. So convert subtraction to an addition. So in other words, we take the subtraction and we change it to addition, and we change the sign of whatever we're subtracting. Then the same rules for addition apply. So then we follow these rules for adding, because once we change it to an addition sentence, then the rules are the same. So let's look at an example. Let's just do 11 minus 6. 11 minus 6, which we know is 5, but let's see it formally. It's going to be 11 plus negative 5. So we're adding different signs, so we're going to subtract. When we subtract 11 minus 5 is 6, and the bigger absolute value is positive, so the result is positive. What about 6 minus 11? 6 minus 11, we take 6, and we convert this to plus negative 11. And 6 plus negative 11, different signs, we subtract. So again, it's different backwards. Oh no, how did that become a 5? Whoops, this should have been a 6, and this should have been a 5. Oh, bad. Oh, simple addition problem there. Okay, so 11 minus 6 is 5, because 11 plus negative 6 is 5. This is a 5. Okay, here 6 minus 11, we take 6 and we change this negative to a positive, and we change the sign of the other number. So we're adding 6 plus negative 11. And when we do that, we subtract the two absolute values. 11 minus 6 is 5, and the bigger number is negative, so the result is negative. What about negative 6 minus negative 11? Negative 6 minus negative 11. So this is going to be, we change the sign of this, so it's negative 6 plus, we change that sign to 11, and now we have the same thing we had. Well, it's not the exact same, because this one's negative. So we subtract 11 minus 6 is 5, and the bigger number is positive, so the result is positive. Let's look at one more. How else could we do this? Oh, how about negative 11 plus, negative 11 minus 6. Negative 11 minus 6. So negative 11 minus 6 is negative 11 minus, plus negative 6. Negative 11 plus negative 6. The same sign, so we add. The result is 17 when we add, and they're both negative, so the result is negative. So when we subtract here, we're going to get further negative when we take more away from negative 11, so we're going to add. And this is a step that you should be able to do in your head in a few weeks, like that. I know that sounds scary, but this is the hardest part of math. This is what Einstein struggled with, and the only way to get good at it is to practice, 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 practice. Okay, let's look at a application problem, and we'll conclude the video. A meteorologist reported that the day's high temperature was 27 degrees Fahrenheit and the low temperature was negative 6 degrees Fahrenheit. What was the difference between the day's high and low temperatures? Okay, so the difference means we're going to subtract. So we'll take 27 minus negative 6. So that's the difference of those two. So we subtract a negative. That means we're going to change this to a positive and change the sign of that to 6. And 27 plus 6 is 33 degrees Fahrenheit. So the difference in the two temperatures was 33 degrees Fahrenheit. If you need further help on this, message me. I can give you some problems to practice with. Practice, practice, practice is the best way to get good at signed numbers. The next topic is a little bit easier. It's multiply and divide signed numbers. I look forward to seeing you then. I appreciate you watching.